Phaethon, the crash or the impact of celestial body between Mars and Jupiter that changed everything on our Earth. How the impact of a celestial body between Mars and Jupiter changed everything in our solar system, basically. There's a hypothesis that once upon a time between the planet Mars and the planet Jupiter, there was another planet. And according to the same case, it was called Phaethon. At some point, this planet exploded for unknown reasons, and in its place have been left thousands of pieces of debris in orbit that astronomers call the main asteroid belt. And you'll read an article that refers to the impact of an asteroid in the same place that the planet Phaethon once was. According to the hypothesis stated, nowhere in the article is it mentioned whether the asteroid and Phaethon are identical. It's a correlation from reports which, of course, may not have a basis. However, if it does have a basis, the following information may be interesting, which, of course, may not have a basis. Let's see what it says. The following data is interesting. The impact of a huge asteroid filled our entire solar system with large amounts of dust, causing a rare ice age that thus boosted biodiversity, according to new Swedish research. To date, efforts have been made to investigate whether space events affect the evolution of life on Earth, but this study, published in the journal Science Advances and conducted by the University of Lund in Sweden, is the first to show that 450 million years ago, an asteroid somewhere between Mars and Jupiter crashed, and the dust from its debris breakage spread everywhere into our solar system. This accumulation of dust and debris prevented some of the sunlight from reaching our Earth, causing its temperatures to drop dramatically over the next 2 million years, leading to an ice age. The climate changed radically and reshaped from the relative homogeneity to the almost complete division of the Earth into two climatic zones, one Arctic at the poles and one tropical near the equator. The animal species evolved in accordance with the climate, with the result that many of them remain unaffected by the hot temperatures and others can survive in new frozen areas. At the same time, the increased biodiversity among invertebrates was another attempt to adapt to the new climatic conditions. This is the first time that dust from an asteroid crash has been found to cause a significant drop in temperature that triggers an ice age on Earth, said Birger Smith, professor of nuclear physics and geology at Lund University in Sweden. He even added that what happened to the asteroid is analogous to breaking a vacuum cleaner in a room. It's just a large-scale rupture, Smith said. Scholars, in an attempt to shed light in the case for this ice age, searched for evidence of ancient limestone in areas of southern Sweden and near St. Petersburg, Russia. In fact, they searched for remnants of the destroyed asteroid, and as part of this effort, acids were used to dissolve more than a ton of limestone from different areas. It was found that after the destruction of the asteroid, that accumulations of grains that matched its chemical composition increased 1,000 and 10,000 times. These levels remained high for about 2 to 4 million years. Schmidt explains that the grains come with dust, so when they are increased, one can reasonably conclude that there were also increased levels of dust. At the same time, an important method that led the researchers to the present discovery was a measurement of the sun in fossilized sediments on the seabed in southern Sweden. The dust traveling in the solar system was bombarded by the solar wind, enriching it with sunlight. In summary, evidence from rock formation suggests that the Earth experienced an unusual, short-lived glacial period about 466 million years ago. The drop in temperature trapped water under the ice that covered much of the planet, causing a global sea level drop. The period coincided with the increase in the diversity of life on the planet, as most of the then existing species still lived in the oceans. According to researchers, this unexpected discovery could open new avenues in the fight against global warming, if we ultimately fail to reduce carbon dioxide emissions. Global warming continues as a result of carbon dioxide emissions, and the increase in temperature is greater in large latitudes. According to the Intergovernmental Panel on Climate Change, we're approaching a situation reminiscent of the conditions that existed before the asteroid collision 470 million years ago. For the past decade or so, researchers have been discussing different artificial methods of cooling the Earth in the event of major climate catastrophe. It's been shown that asteroids such as asteroids and things like satellites could be placed in orbit around the Earth in such a way as to continuously release fine dust and then partially block the warm sunlight, according to reports from CNN. This I've translated for you from a Greek article. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.